time now to formalize the connection between first semester calculus and second semester calculus. So here's the big idea. Integrals and derivatives undo each other. So just like you learned about logarithms and exponents, and they undo each other, you learned about square roots and squaring, they undo each other. Taking derivatives and integrating undo each other. So that's formalized in what we call the Fundamental Theorem of Calculus. And the Fundamental Theorem of Calculus has two parts. In informal language, the two parts are essentially derivatives undo integrals and integrals undo derivatives. But we're going to give formal answers, and there are places for both of the parts of the Fundamental Theorem of Calculus on your important facts paper. Some books refer to the first part and the second part, or the first Fundamental Theorem of Calculus and the second. It's not that you need to know which part is which. You need to know the two parts, and together they form the Fundamental Theorem of Calculus. So we're going to focus on one part, which I'm only calling the first part because we're talking about it first. And that's if you have a function, like we just saw in 5.3 for the first time, a function defined so that its upper limit on an integral is the input variable. So here I have this x. That's my input variable. If I have a function defined like that, and I take the derivative of that function, the derivative undoes the integral and leaves me the function I had in the integrand, but with a new variable as its input. So if I have the integral from a to x of f of t dt, and I take the derivative with respect to x, that's what this operator means, of that integral. Notice how my old integrand was f of t, my answer, the result of differentiating that integral, is the same integrand, but with that upper limit variable as the input now. So let's practice using the Fundamental Theorem of Calculus to take the derivative of a function defined with an integral. So three things have to be true before we can be guaranteed that our derivative will undo our integral. We have to be taking the derivative of, so that's this operator, d dx, means take the derivative with respect to x. And we have to have a function defined with an integral. Okay, that's the easy part. The variable that we're taking the derivative with respect to, this x, has to be a match for the upper limit of our integral. So those are both the letter x, so those are a match. If those two things are true, we have to check the third thing, which is the lower limit of the integral has to be a constant. It could be a number, or it could be a letter if we're told the letter is a constant. Or it could be pi, it could be e. It has to be a constant. If those things are true, then when we take the derivative undoes the integral and leaves us the integrand, but instead of the old input variable, the upper limit of the integral becomes the new input variable. All right, let's check this out. That's what the it's the fundamental theorem, half of it says. So before we do this problem using the Fundamental Theorem of Calculus, let's evaluate this derivative of an integral problem without using it. Because you actually know how to simplify this expression. This says, take the derivative with respect to x of the value of this integral. Well, we learned in the last section that we can evaluate an integral with an antiderivative. So I can find an antiderivative for cosine. That would be sine. I'm going to use those limits. That says evaluate sine of t from negative pi to x. This is the derivative operator waiting very patiently for me to finish the rest of the problem so I can take the derivative. So this is going to be sine of t evaluated at x minus sine of t evaluated at negative pi. So this big arrow to 0 just means when I take the derivative, well, it doesn't matter if you don't remember what the sign of negative pi is, it's some number, and when you take the derivative of some number, that's going to become 0. So you're going to take the derivative with respect to x of sine of x, and we all know that that is cosine. So that's sort of a long way that we can take this derivative. I'm going to move my little picture out of the way. I'm going to take the derivative the short way using the Fundamental Theorem of Calculus. All right. So the derivative with respect to x, what am I going to check? I have to check for 3 things. I'm taking the derivative of an integral. My lower limit is a constant. Negative pi is just some number. My variable that I'm taking the derivative with respect to and my upper limit are an exact match. If that is the case, then I can simplify this integral by saying, oh, my derivative is going to cancel out my integral, leaving me my same integrand, but with the input variable change. So my input variable is going to become x cosine of x. Which is the same answer I got when I did it long way.